with some solar modules. And a big welcome today to the launch of the Gamesa Electric Proteus, the new generation of central inverters for PV and storage applications from Gamesa Electric. A new inverter is one thing, but what it all means and what it means for the levelized cost of energy, or LCOE, is the main topic of today in a busy webinar program. So a few highlights of what's to come and what to expect. Obviously, the presentation of the new Proteus inverter and the evolution in the product from the Gamesa PV3X series of inverters that came before it. The 7 proven ways to improve LCOE, including how the new Proteus provides added value, revenue, O&M improvements, and that all-important lowering of LCOE. We'll also see a case study, some real data out of a 50 megawatt PV plant in southern Spain. So this should be quite interesting for everyone involved, as it's not projections or simulations, but actual data from the ground. And also, just so you know, in a little preparation event we had before, I saw something I hadn't seen a lot of before, which was O&M insights into some critical component lifespans. So keep your eye out for that a little later in the presentations. And now to our speakers today. If you could both turn on your cameras, please. We have... Hello, gentlemen. So first we have Antonio Montoto, Sales Manager, Storage and Hybrid PV, Gamesa Electric, who will present the Proteus inverter and explain the evolution in the product from the popular PV3X series of inverters from Gamesa. And Enrique de la Cruz, who will start us off today. And he is the Solar and Storage Sales Director at Gamesa Electric, and will detail a case study from that 50 megawatt PV plant in Spain, which has been in operation since 2021. And seeing real performance from the plant and how it exceeded the expectations of the plant's designers, especially in production and availability. For all attendees today, a Q&A session and discussion will follow these presentations. So of course, feel free to submit your questions. And just chatting with the team earlier, the Proteus will be unveiled officially at Intersolar Europe in just over a week. So you might have some questions for the team on the ground after this event. So look out for them. Look out for PV Magazine on the ground at Intersolar as well. And before we start, I'll just kick off a little bit of housekeeping for some questions we often get. As I said, please do feel free to send in your questions. We may get to them during the presentation if they're about something specific. So write those in via the big marker control panel. We've already had some questions come in pre-event, and I can only assure you that with your questions added into the mix throughout the presentation, this will be a better event. Now, one question we always get is, will the slides be available afterwards? Yes, all registrants will be receiving an email from the system with a link to the recording, which can then be shared with friends and colleagues after our event today. And of course, for anything else, the PV Magazine webinar team is standing by to answer any questions you have about the webinar software or other administrative matters that might come up. So we'll get started today. Enrique, you're up first. So we're all set to hear from Enrique de la Cruz, Solar and Storage Sales Director at Gamesa Electric, to introduce today's program. Take it away, Enrique.
Well, thank you very much, Tristan, and thanks everybody to join this webinar. It's a great pleasure for Gamesa Electric to be present today in this event organized by PV Magazine. Thanks very much. I think that the PV inverter industry has suffered a tremendous transformation in the last 15 years. I started selling inverters back in 2005, 2007. When selecting an inverter was like selecting a commodity. It was about price. It was about euro per watt. As of today, we are all in the industry, and we know that choosing a PV inverter is probably one of the most critical decisions to make when building a PV plant. There are many things involved in the selection of a PV inverter, but if you make it right, your profitability will be safe, will be secure. The goal of this webinar is to tell you why do we think so? Why do we think it's so important, the selection of a PV inverter, and to help you to make the decision in the best possible way. Before to go to this level of details, we have prepared a presentation where you will see, as Tristan introduced, different things which are critical, important for you to consider. The title is 7 Proven Ways to Improve LCOE. We hope at the end of this webinar you will have a clear idea of why our product is proposed to the marketplace. But before going that, if you allow me very quickly, I'm going to tell you who we are. Gamesa Electric is a company 100% owned by Siemens Gamesa. Probably we don't need to introduce Siemens Gamesa. Is I would say the leader in the market in renewable energy in terms of wind turbines, in terms of offshore and onshore applications. We are present in more than 90 countries with revenues in excess of 10 billion euro and a footprint of almost 120 gigawatt installed wind turbines in the market. A very important part of this footprint, like 80 gigawatt, is consisting of turbines where we, Siemens Gamesa, our employees, are doing the operation and the maintenance. This is critical. This is fundamental because all our portfolio is designed with the criteria to be very easily maintained and with a very, very high reliability. You can imagine that having converters components in total in the top of the nacelle of a wind turbine demands extremely high reliability. And that's our heritage. In PV, we're going to talk about PV today, PV and storage. We are heritating all this experience from many, many years in the wind market. Gamesa Electric, being part of Siemens Gamesa, is dedicated to the manufacturing of components. Basically two technologies, generators and power electronics. We are going to talk today about power electronics. And in this field, we separate between wind converters. As you can see in this slide, we have installed in the market almost 30 gigawatt of wind converters and solar inverters. We started later in the time, but we have already reached the threshold of 4 gigawatt installed in different countries, different continents. We are doing this in 8 production centers globally in the world. We have 3 factories in Spain, one in Madrid, another one in Valencia, and a third one in Reynosa, in which we manufacture the rotating machines, generators, basically for wind market, but not only. And then we have 2 other factories in India, 2 other in China, and another one in Brazil. That's our footprint worldwide with more than 900 employees. We are in the market since decades, and we were the first company installing a 1 megawatt power plant, PV power plant in Spain, in Europe, I will say, back in 1993. So we have a very, very large experience in PV, even if our footprint is growing, but not at the level of many other large companies in the world. Talking about PV, specifically the solar inverters, we have run through different generations of products, but as of today, this is how it looks, our portfolio. Very simple. We have a new family, a brand new family of inverters that we are going to launch officially in Intersolar next week. The name is Gamesa Electric Proteus. And being new doesn't mean that we have just designed this product. It is a long history behind. It's an evolution, and a smart evolution, let's put it this way, of the different products that we have been selling to the market, first in wind and now in PV. On the converter side, we have the Proteus PV, obviously for the PV plants, but we also have the PCS for energy storage applications, where we can combine it with a DC-DC converter for those potential applications which are DC coupled. And of course, being the core of the product, we integrate it into complete power stations. We sell plug-and-play solutions where the inverter or the inverters, if we put 2 of them back to back, combined with state-of-the-art medium voltage transformers and switch gears and all the elements that the customer may require, put together a complete solution which is ready to go to the market. And then, of course, we can combine this with some other auxiliary elements. In case of battery storage application, we can include as well skids for battery integration later on. And last but not least, for sure, the plant controller, which is a proprietary device, a Gamesa Electric Orchestra, that has been recently launched to the market, which can be used for any kind of PV, storage, or hybrid application. Before we go into the details of the seminar, and as I said before, to try to tell you how important is choosing the right inverter, let me finish with this. I said about the smart evolution of utility scale inverters. These are the inverters that we are going to launch in Intersolar, as I said before, manufactured in Europe. And let's keep in mind these key messages before we go into the details. These are the inverters with a higher power density in the marketplace today, with the highest efficiency, with the highest range of temperature, providing with the longest lifespan for maximum reliability. We can provide stations up to 9.4 megawatt full power. At the end of the presentation, I will give you a short summary with success story, and I will answer all kinds of questions. But I think it's time to move to the next speaker, Tristan.
Yes, thanks, Enrique. Appreciate that little rundown there of Gamesa Electric. So it's time now to bring on Antonio Montoto, Sales Manager, Storage and Hybrid PV at Gamesa Electric, with the main presentation of the day, running you through the new Proteus. So, Antonio, it's all yours. Take it away, and we'll be back with you soon.
Thank you very much, Stan, and thank you, Enrique, for the brief presentation about the company. Yeah, regarding the main subject of this speech, of this presentation, we will start by introducing the overview that LCOE is from a point of view of an inverter technologist. We will try to highlight how our inverter introduced significant improvements and increase the chances of reduction of this ratio. Regarding the 7 proven ways, we have a group into 3 blocks: efficiency improvement, loss reductions, and the adjusted cost. For higher efficiencies, more related to the main features of the inverter. Reduced losses is a very interesting way of taking advantage of some aspect of the plant that now are considering as inevitable losses. We consider that you can turn into a benefit for the plant. And finally, we will see some design strategies and characteristics of the inverter that can impact positively both in CapEx and OpEx, and reducing maintenance and gaining a much higher lifespan in the plant. And finally, as Enrique has mentioned, we will show a real case in Spain, launched in 2020 and 20. We will show that in 20 and 21, we have managed to improve production by almost 3% compared to what was foreseen in the original business plan. Okay, you can see here the well-known general formula for LCOE, the levelized cost of energy. In short, improving this LCOE from the technology's point of view is about reducing the installation and maintenance costs while increasing the revenues. And that's all. Keeping this in mind, and depending on the possibilities, there are different ways to try to improve this coefficient. This is not a secret, and of course, it's not a secret that we operate in a very dynamic and competitive sector that evolved to improve this value. As Enrique mentioned, I began in 20 and 5, and the largest central inverter at that moment was about 100 kilowatt. And now the Proteus has a 4.7 megawatt. It's 50 times more power and just twice the size. Then we recently make an exercise to see what's the real scenario today regarding the inverters. And we compare the situation with high-level athletes who give their best to reach the top. And every of them with different strategies, improving different things, trying to reduce this coefficient and to give more to the customer. But sometimes there is a runner that is capable of standing out from the others for several reasons, several factors. In the case of technology, this must be specific based on data and able to open new possibilities of improvement. That's the way we see our machine. We think that due to the characteristic of the Proteus solution that we are releasing on May, we think that it could suppose a real difference to the others. But why? You can see here the main features of the power inverter. We are really very proud because we offer the record efficiency, the highest temperature range without derating, and achieving a minimum derating in the highest ambient temperature where it's reasonable to work. We offer the lowest THD, the true harmonic distortion, that we will see later what it could suppose to the plant. And there's some other option that can help the large scale, both solar and battery plants to meet their goals regarding benefit both economically and for the ambient, to be more sustainable. But let's go with the first of them. We will make the first two in the higher efficiency group, and we begin with two parameters we just have mentioned that are the ultra high efficiency and the MPPT efficiency. We talk about ultra high efficiency not only because we have a peak efficiency of 99.45%. This the biggest in the market for central and the biggest in the market for utility scale. But the efficiency is almost ever above 99%. This is thanks to the work that is joining both the cooling system, the highly tuned hardware that is developed inside the Proteus, and the control algorithms that are running over on the control board from Gamesa. And we have to take into account the standards, the EAC 616683 requires that efficiency measurement must be done in a power factor of 1. But when the inverter is generating reactive, this efficiency usually degrades because reactive involve higher losses, especially in the inductive components. But our inverter offers the same efficiency regardless of the power factor. Power factor is not only related to the grid code. Sometimes in a plant places in a very strong grid, you're required to tune the power factor, for instance, to compensate internal losses, to compensate internal behavior of the plant. Then, in any case, you are not losing the efficiency that is in the data sheet, and this guarantee that performance is not degraded. Ensure maximum plant production, and we consider that this obviously help to reduce the LCOE. In the table, you can see in the left the dynamic MPPT efficiency of the equipment compared with some top-tier inverters. This is public info that you can see in the data sheet, in the technical data of different inverters. And it's easy to verify that we get more than half a point of practically all cases. The way in which we extract the energy from the panel is a record in the sector. This is the highest up to the date. And as a result, the amount of energy that you deliver is higher. And of course, this will be more production for the plant, and of course, it will reduce the LCOE too. These features, apart from the feature I mentioned about the efficiency and some other, are included as a standard in our inverter. This is very important because it's not an extra or a surplus that you have to ask for if you want. And it will be very interesting with Enrique talk about the real case in a few minutes, and you could see how our customers are taking advantage of using Gamesa Electric's solution. Let's go to the second way that we name it maximize every opportunity to produce. We reduced the minimum MPPT voltage range by 2% compared to the standard values of power inverter currently on the market. And how? There is some restriction regarding this, because if you reduce the range, you could have some troubles with the apparent power, with the level of reactive power that you require to do that. But we use firmware that is full adapt to the capabilities of the conversion and filtering stage in the inverter to manage those distortions. And in short, we are able to start production sooner with a lower DC voltage level. And this, of course, without degrading the harmonic content of the power source regarding the normative, which, as we will show in the next point, is really a very, very good feature, and we think that it places our inverter like in the top in the market, because he continue working at minimum level even we work in this way. And it's very important to mention that our converter control platform is a native development from Gamesa Electric. It's a work operating tens of gigas, both in solar, wind, or storage, since more than 10 years ago. This led us to tune and to refine more than others our power architecture. Of course, as I like to mention in the end of every slide, you increase power yields, you have more flexible design, you reduce LCOE. We go now to those more related to transform losses into opportunities of more profits and more benefit for the plant in general. For the next one, I will take some more minutes to explain from scratch what are the benefits of the reduce the THD in the inverter. The international reference standard 235, the inverter, regarding the THD, tell us that this distortion must be measured up to the 50 order harmonic. That is 2,500 Hertz. And of course, never exceed 3%. But the switching frequencies, commutation frequencies of the inverter are much higher. It could achieve 7 to 15 kilohertz. In fact, it's in this range where a power inverter based on electronic produce the greatest distortion. Then, according to the standard, inverter are not displaying the through harmonic spectrum and the through THD, the through distortion. But if in a current plan we put a network analyzer and connect in the inverter terminals and put another one at the connection point in the plant, the POE, we could see that the amount of current that you measure in the POE regarding that measure in the power inverter output is lower than could be expected only by ohmic loss and the nominal loss in the different stage. You have to take in your mind that the energy you are measuring in the POEs, the energy you will be paid for, is the content and the related to the profitability. Then what happened? That you're losing a bit of energy because the high frequency harmonics are dissipating in the different stage. A part could be dissipated by phase shifting. That is a technique that the inverter use to trying to reduce this component by suppression of one with another equivalent. In this case, you can avoid a big part to go into the rest of the plant, but you're losing that energy in any case. But the part that is resting to that, the surplus from that, will be lost in the transformer that is designed to work in the 50 or 60 hertz, and high frequencies will be lost in like a heat, but can damage can accelerate the degradation of the transformer, or in the wiring, in the cables, or in the any part between the inverter and the substation transformer that will be impacted too by this. Then the presence of high-frequency THD make the plant to behave like a low-pass filter, absorbing the high-frequency harmonics, dissipating them in heat. And the most important cause of failure of a medium voltage transformer is high-frequency harmonics current disturbance. I put an analogy that is you have a good THD at the end, is under the required by normative 3%, but it's like if you it's served dirty water, but the idea is that your kidneys can do some of the work for cleaning. The impact is out of the inverter itself. If we compare this behavior with the behavior of a Gamesa Electric Proteus inverter, we see that we incorporate a really very effective low and high frequency filter to avoid those harmonics. And this ensured that both low and high frequency and desirable power are minimum at the inverter terminal. What you're measuring in the end and what you're measuring in the point of interconnection is clean. You are drinking clean water from the beginning. That's a responsibility that we take for the plant. And it's a thing that we can translate into numbers to see what could be the real impact. We made a 25-year analysis comparing us with other central inverters that are using a conventional high-frequency filter, and we are comparing with a string inverter that use only phase mitigation without a high-frequency filter. This basically because a string inverter usually don't have space enough to incorporate this sort of filtering. If you see the direct saving obtained by reducing the electrical losses is evident, and without taking into account the impact that repair or replace the transformer or other degraded element could have. You can see that the energy you are wasting along a common lifetime could achieve more than 4 million euros. Then we consider a highly impacting number, and we consider that this is really one of the top features of the power inverter that is not easily asked in the meetings, because it's not yet in the vision of the customer to ask by this. They consider this is inherent to the plan, and we think we can improve. Then, apart from reduce these losses, for having more revenues, you increase the grid stability and you avoid a potential transformer breakdown risk. Then, of course, we think that this is from the point of view of a EPP, of a power operator, a power asset manager, you are reducing, of course, the LCOE coefficient. And we go now to another feature focuses in taking more from energy that is not well used. And this we name the 100% performance. If there is clipping, it's more energy available in the DC bus than the inverter's nominal capacity could convert, the inverter is prepared to extract a few additional kilowatt from a photovoltaic field and use them through its auxiliary service transformer. In such a way, they become a usable, a free energy for the customer, because otherwise it would not have been possible to use it. Based on this, we recently modeled for a customer a case in Antofagasta, Chile, for a plant with 20 inverters, a DC-AC ratio of 1.3, and taking into account two cases. When you are using fixed arrays, and we are using a tracker, a one-axis tracker. And you can see in both cases, we are talking now about the first case, the 1.3, you are having an extra revenue of 250,000 euros. That's equivalent to a part of the plan that you are receiving for free. Then it's and apart from that, you are using clean energy that is wasted in other case. Then it's more sustainable, more profitable, and of course, it's can reduce the LCOE. And we go now to the block based in the adjusted cost. We will show these three, but you remember that every way is can be listened independently. If you come a bit later, don't care, because you can see in other moment, but you can follow with no problem what I am talking in every of the different approach. Okay. We name this bigger is better. As Enrique has mentioned, we are a company mainly focusing central inverter with high density capabilities. We are talking about a maximum station about 9.4 megawatt full power. But the question is not only being bigger, is if this size could suppose a benefit to the plant, to the customers. We take a second to see that the panels have changed in just few years, evolving a lot. The increase in efficiency has been very significant, and in the same array we have much power per square meter than only 4 years ago. You see that in the twice surface you have 91% higher power. If the inverter don't accompany this growth, could be necessary to multiply the units installed in the field to cover the new plants. You require more inverters similar in power to cover more panels. We see here a comparison using the latest PV panels with a 5 megawatt station and a 9 megawatt station. You see that in the first case we're using about 11 stations that must be connected to the different stream fields and following the configuration of the plant. And in the second, you are using only 6. This is not only translated in the number of stations, of course. We translate this in the less use of space, foundations, wirings, logistics. There are potential less use of power transformer that nowadays is a problem sometimes to manage the purchasing, and implies a significant energy saving in the logistic, transport, and installation that result in fewer emissions, both in manufacturing, logistic, and installation. Then it's a potential reduction of the LCOE that sometimes it's not very well known for the customers. But following with the same topics about the sizing and focusing in the Gamesa Electric Proteus, we see some figures here. Our station reached 0.34 kilowatt per kilogram. The average is 0.24. I think the second in the market is 0.3. We are much higher in the concentration of energy per kilo. It's supposed as saving in as I mentioned, saving in emissions, saving in money for transporting, and saving in the utilization of the plant. But if we see the second figure regarding the surface, we are the leader too in the watt per square meter. We have the higher power density both in volume and in surface. We have the highest power block in the market. But these two figures have a special sense if we see the third factor is that all of these can be including only one container. A high-Q container can transport a full station, full assembly in factory, and you only require to pick up and put in the final placement. sometimes you purchase the station, but you have to take different part and put in the final place and connecting. Okay, this is by default is not needed for us. Okay, and in any case, we have different configuration of integration depending on market and customer request. Okay, then we think that these details are gaining a lot of relevance now with the increase in transportation costs, logistic troubles, and always looking for the more simple project for the customer to be developed. And we think that this benefit at the end reduce LCOE and are more friendly for this for the nature that at the end is the main objective of the market, no, of where we are working. We see now the Coolbrit cooling system. The Coolbrit is the name of the the hybrid liquid and forced air cooling system we use. We dedicated a webinar with PV Magazine 2 years ago talking about the benefit that it can bring to the product and of course to the customers. And I only want to mention that we are pioneer in the use of this system in PV and storage. In fact, we have been manufacturing a water-cooled converter for wind and solar for more than 18 years. And we apply the same safety margins that you use in wind or in other sectors where Gamesa working based on this technology. It's said that those who start working with a liquid cooling system don't want anything else. And why? From the point of view of engineering, the working with liquid cooling allows to have a very compact solution, and especially in the heat sinks, at a smaller, more compact than the equivalent in air, and lets the engineers to have a more great of freedom to make better internal designs. Apart from that, we are using this liquid cooling for the AGVTs and the filter coils, and these two elements account for just over the 75% of the thermal losses inside of a photovoltaic or a storage power converter. In this way, practically all the heat that is generated inside the equipment is evacuated with the most efficient cooling system in the market. But for the rest of the part, more smaller, more heat dissipating, demanding, such switches, circuit breakers, PCBs, fuse, they have less thermal losses and can be cooled with forced air. In this case, we optimize the cost of the solution while we reduce the maintenance because the filter saturation is less, because the airflow is less that we're using only a full forced air solution, for instance. And apart from that, I have to mention that our filter have a sensor that can active an alarm to the maintenance people, to the asset manager, to change only under demand and don't have to be looking every time how is the filtering system. But apart from that, and this is a very common question of our customer, cooling system have a very little maintenance and very simple. You only have to change the liquid every 5 years, and it's a very routine operation with a market available cooling liquid. It's not really specific and is friendly with the ground, friendly with for ambient reasons. And the design is an essential element in the operation of our inverter. It lets possible to have the number we have in efficiency or in the THD and in the rest. And we consider that working with liquid cooling hybrid with forced air is key to have this solution, and is key for this reason to reduce the LCOE.
Antonio, just Tristan here again. I was just going to ask you just a quick question. So you said routine maintenance. You change the liquid once every 5 years, and the liquid isn't overly complicated or scarce, so it's relatively normal.
No, it's like changing the water in a deposit. You have only to open the entrance for the liquid. It's a propylene glycol. It's a mix between water and an organic substance, but absolutely passing all the control regarding that it's not a risk. If there is an escape for the ambient, there's no problem in that. And any operator with a correct learning course can make this change of this liquid. It's a closed circuit, because that's another common question for customer. But you have to connect to an external liquid source. No, it's completely closed, isolated. That is only like changing the liquid of a car deposit of water, for instance, the refrigerating deposit of a car. Then it's very simple, and the simplicity for the rest of the inverter compensate a lot, because you have less force fans, for example, for air fans, and in general the maintenance is more easy than with a forced air system.
Okay, no worries. No, that answers the question we had. So, yeah, please continue.
No, thank you. No, I was finishing this slide talking about that. It's a good point to reduce the LCOE. It's easy to believe that it's a good solution, because you could see that a lot of competitors are trying to take this solution too, for one reason, because it's better, and we have been using for, I say, 18 years without changing, except the natural evolution of the technology. And we go finally to the seventh way that I consider very interesting, and that people who usually work in the plants, I think that that could be very relevant. And it's to see that we are using an inverter that is designed so that the component work far beyond their functional limits. It's a bit oversized to avoid forcing the components, and to ensure that the inverter can use them through their useful life without problems and avoiding replacement. But additionally, thanks to the cold breeze cooling system we have mentioned, this allows the component to work far from their thermal limits. For instance, I think that some of them have thermal limit of 180 degrees Celsius, and we're working under 100 or similar. It's not only a margin; it's a really large margin of tolerance we are respecting regarding the manufacturer specification. Then the life of the inverter is more than 30 years, only with preventive maintenance and only changing the reasonable components like fuses and the tear and wear element common, but not the key element. And this reduce all the costs associated with the project. I put here, you can see the IHS analysis conclusion to understand that it could be a very important reduction. They talk that 25% of the inverter O&M is the replacement at the middle of life, or at the 2-3 part of life, because some of the key elements like AGBTs or the AC inductance or the breakers required for a replacement. And you can see in this table we put the working condition where we make the analysis. These results were obtained in a report carried out in the certification and validation process for the American market, and is tested by us but approved by an independent entity. The working condition of the equipment and the design criteria is extreme. Maximum power at 55 degrees of ambient temperature for 12 hours. And considering that it's working with a cool night feature, that it's included yet in the inverter by default, generating night reactive for 12 hours a day during the nights. Then we consider that inverter is working at the maximum level in 24/7 along the year. Then if we obtain this data, we are talking you that the risk associated with inverter replacement are really limited. And why? Because if you are using a common inverter in 15 years to 20 years, the inverters required to be changed total or partially. But the technology, as we could see in the slide regarding the panels, technology evolves. And not only in the inverter, also panels and the IGBTs and some others. Then could be possible that the equipment or component available on the market doesn't fit properly with our needs at that moment. That's really the case in some installations that were done 20 years ago and with a very hard, very hard condition to replace the inverter of 20 years old or 15-year-old. Then we avoid the problem. We reduce not only cost but also risks. Then we consider this a highly relevant feature that at the end is a consequence of all that we have been talking in this presentation about these 7 ways. Then you can see in the next the path we have to follow. And now, Tristan, if you want, we can go to the next part.
Yes. Okay. Great. Thank you, Antonio. So, okay, for everyone, in case you've joined late, we've been hearing from Antonio Montoto, Sales Manager of Storage and Hybrid PV at Gamesa Electric. He's been walking us through the Proteus inverter and those 7 proven ways. And I guess they're proven, or we're about to hear why they're proven, as we'll hear from Enrique de la Cruz, Solar and Storage Sales Director at Gamesa Electric, presenting the real case study we've been hearing about of a 50 megawatt PV plant in the south of Spain. So, Enrique, if you're there, perfect. All right, take it away.
Thank you, Tristan, again. Well, I'm going to be very, very fast. I think we're running out of time. So the purpose of this part is just to show you or to share with you some of the real information that we have got from the field. First, well, I must say that what we are going to show right now is the result of a real installation that one of our customers did in Spain, in the south of Spain, Andalusia. It was a 50 megawatt peak plant that we equipped with 13 Gamesa Electric PV station, inverter stations. As I said before, and I'm commented many times, we are going to launch the Proteus, the new Proteus product in Intersolar during this year. So obviously this is a product which was not 100% Proteus when we sold it, but it's incorporating a lot of features that Antonio has explained. The most important ones: high efficiency, low THD, 100% performance, and the very high MPPT efficiency. So it's a very good example for you to realize that everything we are saying, everything we are calculating, in reality, it pays off. This is an installation that was commissioned in 2020. It's working for more than a year. And what we are showing here is the comparison between the predicted performance ratio by the customer and the actual numbers. So what you see in orange is the calculation in PVSys, and what you see in light blue is the actual performance ratio measured by the customer. So this difference that you can see more in detail in the next slide on a monthly basis is in between 3%, 4%. In average during the year is 2.67% improvement. It's a tremendous improvement in terms of production and money. I said at the beginning that choosing the right inverter, it's the key for profitability. It's the key for LCOE. This is just an example. Important part here is that, obviously, in the calculation in PVSys, there are already some things which are included. Our high efficiency, record efficiency in the market is already included in the calculation. We have the ONDs, and the customer has run the simulation based on that. But there are other things, as Antonio said, that cannot be calculated, cannot be simulated by PVSys. THD, for instance. In our opinion, because of this specific design in this plant, as you have seen before, the DC to AC ratio was not very high, it was 1.03. So the performance, the 100% performance characteristic here is not paying off too much. So this is most likely a direct consequence of the very low THD, which was already equipped in this previous generation. Other than the annual improvement in PR, the customer has also reported extremely high availability in the first year. During 2021, first year of the installation, first year of the commissioning, we have exceeded 99.5%, which is quite unique. For the first year, normally you have more incidents in the field, and in this inverter, we have measured record availability and record PR. Time is running out, so we will be glad to share more details on this if you have any questions. If we don't have the time today during the webinar, you can address questions to PV Magazine, to us directly, or even better, if you are going to be in Intersolar next week, again, you pay a visit to our booth. We'll be there the 3 days. We have a lot of customers already planned to visit to make a face-to-face introduction of Proteus, but you will be more than welcome to visit and to stay with us. Just to give a few minutes for questions and answers, let me conclude by saying this is the bottom line. It's all about LCOE. It's all about profitability. I think we have given you a lot of clues to really test what's important in an inverter. Energy production, the denominator of the LCOE. The higher the production, the higher the reliability, the better for your plant. OPEX, it's extremely important to have a very reliable product. We have explained you how our design is made so that you don't have to change critical components during the lifetime. At the end of the day, well, it's excellence, what it matters. Gamesa Electric is in the business since decades, providing with the best products for wind, now for PV since quite some time. And it's not by chance that we have been selected by Intersolar for the best product of the year, for the award that is going to be decided next week. We are among the finalists, and we hope to celebrate the award together with you when you visit our booth. Tristan, that's it from our side. We have 5 minutes left for questions, but I will be more than happy, together with Antonio, to answer any questions if you something in the audience.
Thanks, Enrique. Yes, so that's great. And everyone, just so you know, we have arrived at the Q&A session, so lots of questions and interest. We'll do our best. We may be able to go a few minutes over time, but as Enrique said, Intersolar is coming up. So if there's anything more technical or specific, we'll get back to you in some way. So, okay, let's get into the questions. Antonio, you're there as well. Great. Okay, so a few questions are coming on the same sort of topic. So a general question that we'll answer a few of these is, you've shown some impressive data here. There's a big claim about the improvement to those final percentage points for efficiency, total harmonic distortion, taking LCOE quite a bit further down. And you've got that data as well, which is great. But I'll ask the direct question: why? Why you? Why now? What's going on here with your inverter that has made you able to take that next step up? Antonio, maybe?
Yes, we have been mentioning along the presentation, but it's very, very good question. At the end, it's a mix, because everybody in the industry uses the same AGBTs or similar. Everybody use power inverter. At the end, is an assembly, and the main decision, the key decision, is how you assemble this to get your best. And we have the advantage of a long experience developing the cooling system, high refinement hardware, because we use in different platforms, and we know very well our product, because we heritage a lot of knowledge in every generation, and the hardware is another point, and the THD strategy, where it's not absolutely a new discovery in the industry, but it was always in the secondary part of the question from customers. They always, it's assumed that 3% is enough, because it's the historical number, not only for any distribution grid, any grid focus on distribution. We make a filtering system that is only possible to do if you use the other decision, because you require enough space inside. You require not only it's a time of key point. All the bush bar, the way you distribute inside the inverter, the different conductor, to reduce the heat effect is important to them. as Enrique have shown in the first slides, this is the 5th generation of products, and we not only make the disruptive chain of moving from one voltage to a higher voltage, or from moving to one external thing to another thing. We have been mixing our own knowledge once and again, and we think it's like a Formula Uno where in every race you make some better thing than in the past to tune the machine. Then but the two main points are cooling, hardware, and of course the firmware that is managing all that.
Okay, thank you. Appreciate that that answer. A question's coming as well, just around where you are manufacturing your inverters. So Enrique, you mentioned this to start off with. If you just want to recap where the Proteus is being made.
Where is it made?
Yes, exactly.
We manufacture in Europe, in our factory in Spain. Yeah.
Okay, so just confirming. Okay, no worries.
Mm-hmm.
Okay, so just on something on temperature derating. Nice question here. So these days, India and Pakistan are experiencing a record heat wave, and yeah, our thoughts go out to them putting up with those temperatures of up maybe as much as 50 degrees Celsius. So Antonio, you looked at this as well, but does your solar inverter generate power at these temperatures? What temperature does the Proteus solar inverter stop generating energy? What's the temperature derating situation?
Yeah, well, the inverter is designed to work in the hardest environment. India is in our focus, and Enrique can add a few comments about that now. But apart from that, we are, for instance, one of our main markets at US. And some of the hardest places regarding temperature are based in California, Arizona, and in the southwest of the United States. It's a very, very interesting field to test what's your possibilities. Then the point is that if you are working, for instance, in 55 degrees Celsius and you only lose 10% of your nominal power, you'll be over the general plant power because the panel will degrade it more. The transformer will degrade it more. The external element to the inverter will degrade a bit more. Then we are really virtually in full power for all the temperature range. And we're designed, Gamesa designed for main market in the world, not is only focused on in Europe or in Spain. But in this case, apart because you are asking about Pakistan and especially India, Enrique can mention some things because we have our own teams there working for Indian market.
Oh, sure, we have a factory in India which is manufacturing for the local market, but it's the same technology, it's the same design, the same engineering team as in the rest of the world. As Antonio said, I mean, our inverter is able to provide full power, this new Proteus version, from 25 to 40 degrees with no derating whatsoever. So we have a slight derating up to 50 degrees, and even at 55 degrees, we can produce a lot of power. So this is unique for desertic areas, for areas where the temperature can be very high. India, of course, is one of our key markets. I didn't mention at the beginning, but we are, selling worldwide. Our main focus is Europe, Middle East, US, Latin America, and India, together with Australia. These are our markets, and all these areas our inverter is perfectly fitting from the temperature standpoint.
Yeah, sure. And I mean, at 55 degrees, the solar panels themselves are.
Yeah, that's right. As Antonio said, you will never have the maximum power at that temperature.
Okay, so speaking of one of your different regions, someone's asked, they looked at the Proteus PV station datasheet. Can IEC version, which is the 2 inverters, be used in the United States, or is there another version for North America?
Well, in North America, of course you can sell IEC solutions with 2 inverters back to back if customer wants to do so. But typically in North American market, what is demanded is a single power station, a single inverter power station. Sorry, with transformer at the level of 5 megawatt maximum, pad mounted transformer. That's a typical application we see in the US, and today all the projects we are doing in the US are based on this approach. Only one inverter. Yeah.
Okay, no worries. And actually, there's another temperature question in the US, but can you go lower than minus 30 degrees? So on the other end of the extreme end of the temperature scale.
Yeah, I think we can. Maybe Antonio can comment on that. But we have an alternative for heating the inverter for very low temperature applications in some countries where the temperature can be that low. Yeah, that's not an issue. It's a kit that we can incorporate into the product.
Always it's said that the low temperature is more easy to solve than the high temperature. The trouble usually is that the person who is going to maintain sometimes is not prepared for the minus 30 degrees. No, then sometimes the limitation is to be able to work or to make the maintenance correctly in temperature of 40 minus 40 degrees or similar. But from the point of view of technology, you only require for extra heaters, both for the inverter, for transformer, and for all the parts.
Okay. So, gents, we've got a couple more questions. There's a lot of questions, but we'll just see if we can get to a couple more. And this is one I actually missed as well. So, Antonio, you talked about harvesting the clipping losses, and that would prevent inverter losses. Can you elaborate on that?
This is an auxiliary feature because sometimes the plant doesn't have any storage, any support for taking advantage of this clipping. Usually those in market with no regulation for storage, or those projects that are ready to build and doesn't want to make any change. But in market like in Chile, for instance, usually the rating between DC and AC is higher to take all the advantage of the capacity curve, and this is an auxiliary function to take extra energy that during when there is clipping, because if there is no clipping, you have to source normally, no. But when there is clipping, you can take the surplus to make this sourcing. But if the clipping of the objective of the customer is to take the biggest advantage of the clipping, of course, we can include in the Proteus an stage with DC coupled batteries. Then we can go further to the next stage in clipping storage, clipping reuse, using we use as Enrique have shown briefly in the beginning. We have DC converter that can be plugged directly into the Proteus through a connection box, and we can install I think it's a 1-to-1 ratio similar. You can, for instance, connect 8 megawatt or 9 megawatt to the station, and the similar in storage for making not only the internal storage of to follow the flow you want to do with the energy, but to use the clipping. Then this 100% is to avoid wasting energy that you can use.
Yep, got you. Okay, I'm just trying to get through questions as best we can. So back to one on the cooling. Someone asks, how does your liquid cooling solution differ to some of the older 4 megawatt units from other companies, ABB, GE, that have proven to be more costly to operate due to leaks that cause catastrophic failures? So asking about leaks with the hybrid cooling system, how are leaks mitigated? And okay, if there is a leak, how can that leak be mitigated to avoid the critical components?
Well, I think here the answer is simple: is experience. I'm not saying companies like GE or others will not have experience in the marketplace, for sure not. But as Antonio said, in liquid cooling, in hybrid cooling, Gamesa technology is by far the most proven in the marketplace. We designed it for wind. I mean, we said many times that our differentiator here is that we are coming from the wind industry. It's a must to have, let's say, liquid cooling in the top of the nacelle when you do not have a space for air cooling. So we were forced to develop this years and years ago. And after generations of products and years of products, we came to a design which is 100% reliable. It's simple as that. I mean, I think customers need to trust that this is up and running and working. And at the end, it's very simple. I mean, the design itself is nothing too much different from what you have in your car as a heating system. It's a question of having the highest quality components inside, the highest quality pump, the highest quality pipes and connections, so that you will not have any leakage at all.
No, but in addition to this, and I recommend the people who goes to Intersolar to make a tour with us.
Mm-hmm.
We don't have any notification about problem with the cooling system in the past 5 years or 6 years when for the first time in the modern inverter generations. But apart from that, we're prepared to facing that. If, for instance, there is an escape because any pipe have any trouble, there are internal sensor and internal mechanisms to close circuit and to avoid that the liquid could span. Okay, if there is a hole, the liquid doesn't go free to the inverter. It cut immediately, and the potential breakdown of the cooling system doesn't imply a catastrophic problem. Okay, we have safety levels to avoid that situation, but absolutely honestly, we didn't have neither situation of that since I'm in the company and in the past 5-6 years. No, we don't have any problem.
Okay, no problems, guys. Okay, thank you. Look, I think we're running out of time. I think we're out of time. So some plenty more questions here. We'll do our best to pass these on to the team to answer, or as we've been saying this whole time, answer in person at Intersolar. Yes. Look, I think that's a great place to leave this for today. So big thanks to you, for all of you, for joining us today, and to all who submitted a question. We really do value those contributions to the discussion. We hope the answers we've managed to get are enjoyable. So, of course, thanks to our partners here, Gamesa Electric, Antonio and Enrique, for their quality presentations and expertise. And, of course, a special thanks to my colleagues behind the scenes here at PV Magazine. And a shout out to Beatrice Santos, who's always a star for us with our webinars. Otherwise, the April edition of PV Magazine is out now. You can see it there. Yep. And as you can see, it's a nice little cover. And it is our quality edition of the year, which is a focus on testing, performance, reliability, all important features during this ongoing crisis that is driving the need home for more quality solar. There's some dark days out there, but the longer term demand is up for the solar industry as we consider the security of energy supply. And quality is key to solar's ability to step up and fill the gap that many regions are contemplating or dealing with at the moment. And online, we always have fresh solar and renewable energy news published on our online website with the most read stories, including one there, an interesting one on vertical agrivoltaic project in Japan that's south orientated, and one on the ongoing machinations of political influence in solar, with plenty happening in Florida, the Sunshine State. So check those out, and everything else we publish online. But not only that, we have some more great webinars coming up as well. We have 2 happening at the same time on Thursday, but one's in German, one's in English. The German webinar there is about the ecological footprint of an inverter, so the full life cycle cost of an inverter. And then in English, we have maximizing energy independence, new battery storage and inverter solutions from Sunways. So that's just about it. One last thing, a survey will pop up after this webinar. We'd appreciate your thoughts and feedback on to how it all went today. We do this for you, not for us. So any insights will go far. So thank you. And thanks to everyone for watching this webinar, and for wherever you are in the world. I wish you a good day or a good evening, and we look forward to seeing you again soon. Bye now.
Okay, thank you. Bye-bye.
Thank you, everybody.